Okay, welcome back. Today we are going to revisit the quadratic formula, which you all loved from Algebra 1. And I've got the formula right here at the top, opposite of b. I think some of you even sang a song to it, but I'm not going to sing for you. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you can use this formula to find the solutions of any quadratic equation. This is the one method that you can use to find the solution of any quadratic. So let's get busy here. I'm going to get through, try to get through 5 of these. Hopefully I won't run out of time. So I might move a little quicker than normal. So I've kind of got it all set up so you guys can get caught up with me. You should have a guided note sheet. I think Mrs. Tinsley is going to make those up for some of my lessons that are not guided. So this one's already in standard form. You definitely want it in standard form. So my A is 5, my B is -3, my C is -1. So I'm just going to plug them into my formula. So you guys have that right up above. So the opposite of B in this case would make it a +3 plus or minus b squared. So b squared is going to be -3 squared, which is 9. See, this b squared will always be positive. So I'm just going to square that in my head. You know, or if it's a bigger number, I would square it with a calculator. So minus 4ac all over 2a. Okay, so I've got it plugged in. Now the biggest part of this is what's under that radical, because this outside stuff is easy to simplify. But I need to do 9 minus 4 times 5 times -1. I get 29. I kind of started us with an easy one because once you get to there, like there is nothing more you can do with the square root of 29. I mean, we've been reviewing radicals and stuff. I mean, that's no way to break that down, so this is going to be my answer. Okay, so let's move on to number 2. So A is 3, B is 8, and C is -35. So let's plug it into the formula. So the nice thing about quadratic formula, just get it in standard form, have it set equal to 0. You don't need to worry about what the A value is. You just plug it in and then simplify. So opposite of B, plus or minus. So b squared is 8, so that's 64 minus 4ac all over 2 times a. So like I said, the radical is going to be your trickiest part. So let's get that number. 64 minus 4 times 3 times -35. And I get a 4. Oh, now this one's a little different because 4 is a perfect square. So we can take the square root of that. So we get -8 plus or minus 2 all over 6. Now we need to simplify this. So I'm going to do -8 plus 2 divided by 6. And I'm going to do -8 minus 2 divided by 6. So this will be -6 over 6, which is -1. So that's one of my solutions. And this one will be -10 over 6, Well, you can reduce that as a fraction, or you can write it as a decimal. I think that one's going to reduce. It's going to repeat, actually. So I'm just going to leave it like this and simplify it. So it'd be -5/3. So these are your two solutions. Okay, now I've got some more. So you guys probably have a guided sheet for this, like I said, but I need to maneuver my stuff around here. Okay, now this one's not in standard form, so I need to add that 85 over to the other side, because I want the 0 on the right side. So my A is just 1, right? There's nothing attached. That's understood to be a 1. B is -12, and C is 85. So now we just plug it in. So opposite of -12 is 12. Okay, 12 squared is 144 minus 4A and C all over 2 times A, which is just going to be 2. Okay. So let's get that number under the radical. So I'm going to do 144 minus 4 times 1 times 85. I get -196. Now remember, I've been going over the complex numbers. So this is going to be an instance where we're going to get an I, because there's a negative under that radical. Now 196 is a perfect square. So we're going to simplify that just a little bit more. So when I did the lesson, I said, we would keep it as like 196 times -1. So the square root of 196 will be the 14, and then the square root of -1 is your I. So I'm going to go this way. So it'll be 12 plus or minus 14I all over 2. Okay, we're not quite done because all of these are divisible by 2, which means I can reduce it all by 2. So this will go 6, 7I, and 1. But since I have a 1 down here, I'm just going to let that absorb into my answer, and it'll be 6 plus or minus 7I. And that would be my final answer. Okay, let's keep moving. So this one here, still not quite where we want it, because I've got that -7x on the right side. So I'm going to add that over. And that actually is going to go in between the two terms. So A is -1. B is 7, and C is -19. So plug them in. So opposite of 7. And then 7 squared is 49. Minus 4AC all over 2 times -1. So I'm going to simplify what's under that radical here. So 49 minus 4 times -1 times -19. It gives me -27. Okay, now this one, this is a little tricky because The 27, it's not a perfect square. However, there is one of its factors as a perfect square. So if I think about this one, it's going to be 9 and 3 and -1. So I'm just kind of branching it out this way instead of writing it out horizontally. These are all under the radical, so I know the square root of 9 is 3, and the square root of -1 is I, so that would be 3I. So let's go this way. So the -7 would remain the same. I'd have plus or minus. That would be 3I. And then this 3 here is still under the radical. I can't do anything more with that. And it's all over -2. And then if you want to clean up the negatives, like you could actually cancel those negatives. And it would be 7 plus or minus 3 all over 2. So that was a busy one. But see what I mean? Sometimes that radical part can be really super easy, and sometimes it can be kind of tough. I mean, breaking all that down. All right, last one. So this one's in standard form. So let's go ahead and establish our ABC. And then let's plug it in. So 4 squared is 16. All over 2 times A. So let's simplify under that radical. So I'm doing 16 minus 4 times -2 times 7, which is 72. Okay, now that's not a negative, so I know I'm not going to have an I on this one, but I can simplify that. Like, that's not a perfect square itself, but there is a factor that's perfect that can be divided into that. So I'm going to break this into 36 and 2, where I know I can take the square root of 36. So it's going to look like this, 4 plus or minus. So the square root of 36 is 6. But I didn't do anything with this 2, so that 2 is still under the radical. And now I can simplify, since all of these can reduce by 2. We'll want to do that. Become 2, 3, -2. Let me just double check my work here. I plugged in the opposite of b squared minus 4ac all over 2a. So this negative here, like, you know, it's hanging down here in the denominator. I mean, you could make the 2 in the numerator the -1 and make that positive. It doesn't really affect this guy because it's always plus or minus, so it's positive, it goes negative, negative, it goes positive. It just, they typically try to keep the negative up on the numerator. So we could say, or this could be -2 plus or minus all over 2. So however you want to look at that for that last one. Okay, good work. See you later.